So this morning we're going to start off looking at fractions, division, and ratios and their relationships. So to start off, fractions are part-to-whole relationships. So say we have a chocolate bar that has 6 sections, and I want 2 of the sections. That's going to be 2 out of the 6. So if I wanted to add one more section, so I'm going to take that one as well, I would add 1/6, which would leave me with 3/6. Fractions can also be reduced. So if I'm going to reduce it, both 3 and 6 are divisible by 3. So then I would be left with 1/2, which would be the final fraction, which is also representing that 3/6 equals 1/2, which is 1/2 of the chocolate bar. If I wanted to subtract fractions, I could take the 3/6 that I have and subtract, say, 1/6. I want to give one of my pieces to a friend. I would then, same thing, just subtract across because the denominator is the same. So then I would have 2/6 of the chocolate bar left, which could also be 1/3 of the chocolate bar. So if we're adding with different denominators, which is where it gets a little bit more tricky, we're going to have to use the bow tie method. So say you have 2/7 plus 3/5. We're going to have to multiply up and across, and over. So the up and acrosses are going to be the numerator numbers. So 2 times 5, 10, 3 times 7, 21, and then over 7, over 5. So then this ends up being 31 over 35, because we multiplied across still right here. So the same thing is going to go for subtraction instead of addition with different denominators, except this plus would just simply be a minus, and then this answer would obviously be different, it would be a negative answer. But so it'll be the same thing, bow tie method, for both addition and subtraction when the denominator is not the same between the fractions. So next up, we have multiplying and dividing fractions, which is actually going to be less steps than adding them. So say you have 14 over 15 times 5 over 6. You are going to multiply the denominators and numerators separately. So then you're going to end up with 70 over 90, which this can be divided by 10. So then your final answer would be 7 over 9. And you can actually reduce the fractions before or after multiplying. So if you decide to reduce it before, you would have 14, you're going to go across the fractions. So you'll have 14, 6, and 15, 5. So what's a common denominator between 14 and 6? It's going to be 2. So you'll have 7 over 3. And then same thing for 15 and 5, it's going to be 5. So you'll have 3 and 1. So to put them together, you would have 7 over 3 and 1 over 3. So same thing, you're going to multiply across, and you're going to have 7 over 9, which is the same answer we came to up here. So it doesn't matter if you are going to multiply them or reduce them before or after multiplying. Lastly, when you're going to divide fractions, you're going to flip them. Flip the second one. So, and change the sign. So say you have 3/5 divided by 2/3. So what you need to do is you'll keep the 3/5, you change the sign, and you flip the fraction. So now you have 3/5 times 3/2. Same thing, we just like with multiplying, you multiply across. So you'll be left with 9/10 as your answer. So division is pretty easy, just remember, flip the sign, flip the second fraction. So, as we have gone over for the last few minutes, fractions are going to be relationships of part to whole. Now moving on to ratios though, it's part to part relationships. So for instance, if with the fractions we had 5 pieces of fruit and 3 of them were apples and 2 were oranges, you would have 3/5 apples and 2/5 oranges. With ratios, it's going to be 3 apples to 2 oranges, and not necessarily concerned with the whole of 5. So proportions are going to be two ratios set equal to one another. And this is really used to try and figure out a variable's value. So for instance, if I have 3 shirts for every 5 pairs of shorts that I own, and I have 12 shirts in total, so 3 shirts over 5 shorts equals 12 shirts. And I want to figure out how many total shorts I have. So X shorts. Then I would be able to use this ratio and proportion to figure out the number of shorts. It's important to keep in mind though that the 3 shirts to 5 shorts is going to be the same thing as that 3 to 5 ratio and is not saying that I have 3/5 shirts of shorts. So make sure that we keep a distinction between ratios and fractions.